say we had a little problem here. We had an event. We knew some information about the tickets at this event and the prices. It was 10 adult tickets and 5 children's tickets. And that was going to cost $60 altogether. About 10 adult and 5 children. And we know that's $60. Also, we know 6 adult and 8 children's tickets cost $51. Thank you. 6 adult and 8 children's tickets. Okay. All right, well, the question is then, can we figure out how much does each kind of ticket cost? Well, we could take a guess, plug in some numbers, and do it that way. But let's maybe look at it a little different way here and talk about how this at least sets up, and maybe solve it in a minute or two. But anyway, one way we can set this up is set up some equations here. We know that the adult ticket has a price and the children's ticket has a price. Call it X and Y. Okay, well, this first sentence here, if I put that down into an equation, letting X be the adult price and Y be the children's price, well, if I bought 10 adult tickets, that's going to be 10 times X, right? For the price of them, 10 times whatever the price is. And if I buy 5 children's tickets, Y being the price of the children's ticket, that would be 5 times Y, right? Multiply the price times the number we get. Well, if we add those two together, doesn't that equal the total cost there of 60? So we set up a nice, neat little equation. Well, don't we have another one here? And that would be what? What would the equation there be? 6x plus 8y equals 51. Yeah, we still have the same X and Y, same adult price, same children's ticket price. So we still have the X and Y, we just have different numbers there to go with them. Okay. Well, the reason I bring this little problem up here is to show you an example of what we call a system of equations. And how we can use systems in certain word problems like this. Yeah, a system of equations is just like we have here. You've got 2 equations, in this case 2 variables and 2 equations. So you have multiple equations. That's what basically a system is, when you have multiple equations that are related. Now these of course are related because it's the same X and Y value. And that's what we're going to talk about next. But that is an example there of how we can utilize a system here. Now, what we're going to try to talk about next is how we solve those. Because like I said, we could plug in an X and a Y and try it, because the thing of it is, the X and the Y that we try has to work in both of them. It can't just work in one of them, it has to work in both of them, right? Because we've got to have the same ticket price there. So we've got to find an X and a Y that works in both of these, and that's called the solution, and that's what we're going to talk about next. So anyway, just wanted to kind of introduce systems this way and show you how we're going to use it in just a minute. Now, all right, so save this one. hold on to that thought, and we'll come back to it. We've got to do some other stuff first, but we'll solve it here in just a moment. Okay? All right. All right, so let's get back to our ticket problem. I started the lectures on systems with. Remind me what it was. It was 10x plus 5y was 60. 8x, 6x plus 8y is 51. Okay. Yeah, so we had 10 adult tickets, 5 children's tickets were $60. 6 adult and 8 children were $51. All right, so now we can answer the question, how much is each kind of ticket, can't we? Because now we just look at that and we say, hey, that's a what method? Elimination. I can eliminate the one of the other of the variables. Actually, which one would be smaller here? The y's would be 40. Couldn't I get 30 on the x? You could do either one, but the x's would have a smaller LCM. So let's eliminate the x's here. Not much smaller, but a little bit smaller. Yeah, so to solve this ticket problem, eliminate the x's, right? So I'd multiply what? To make that 30, multiply it by 3, both sides by 3. So that'd be 30x plus 15y equals 180. The bottom, I need to make it 30, but it needs to be a negative 30, doesn't it? Multiply by negative 5, both sides. So that'd be negative 30x minus 40y is negative 255. Voila, x's cancel. 15y minus 40y, and then negative 25y, right? And look at that, negative 75 over there on the right. Did I do that right? Okay? So yeah, that tells me, divide by negative 25, y equals 3. So my children's ticket is going to be $3. But I still need the adult, need the x. So I just substitute the y then to be 3. So it'd be 10x plus 5 times 3 would equal 60. Go there. All right, so it'd be 10x plus 15 equals 60. Subtract the 15, so we get 10x equals 45, right? Divide by 10. X is 4.5, yeah, 450. Yeah, remember the X was the adult ticket price, so $4.50 per adult, $3 per child. Much faster doing it that way than trying to guess at it. Okay? All right. Let me give you another one and example of this application. Way we can apply a system. Let's say Jack has $40,000 to invest. He invests some at 6%. And some at 10%. If he wants $3,120 annual return from both, total return from both. how much should he invest in each account? Actually, this one we worked a little differently. I think it was back in chapter, previous chapter, but we're going to approach this from a system standpoint in this particular case. Hence, why we're doing it now. Yeah, we're going to come up with two equations for this this here scenario. Obviously, we've got two amounts. I've got x, the amount in the 6%, let's call it. And then we can call y the amount in the 10%. I can generate here two equations from the given information. Equation 1 is this. Since I know the total is going to be 40,000, wouldn't the x plus the y equal 40,000? So that's an easy one there. So that's our total investment equation. So start with that. Now the other one, and we've seen this one sort of before. I'm not putting it in the table here, but if you want to arrange this in a table. The other one, remember, if we take the interest rate, if we're talking simple interest, take the interest in 1 year, take the interest rate times the amount, that gives us the interest, right? So it takes 6% times x and 10% times y. Well, don't I want that total to be 3120? So let's take the 6% times x, 0.06 times x, plus the 10% times y, 0.10y, and that equals the interest that I want, or the return in this case we're calling it 3120. So that's the other equation here. So we can set up a nice little system that we could solve using various methods. Now this one would be just about as easy either way, substitution or elimination. Let's talk elimination again, just because with the decimals, how we can do that. If I choose here again to eliminate the x's, since that's a 0.06x, couldn't I make that a negative 0.06x? Yeah, just multiply that top equation there. Well, let's do it right here. So I'm going to multiply the top equation by negative 0.06, both sides. And then the bottom equation, just keep it as it is. Let's see what happens. That would be a negative 0.06x minus 0.06y equals negative 0.06 times 40,000 is long about negative 2,400, I believe. Check me on that. I believe it's negative 2,400. All right? Okay. Yeah, so now with the bottom equation, 0.06 plus 0.10y equals 3120. Doesn't that give me something to eliminate the x's with? Yep, the x's eliminate. Negative 0.06 plus 0.10y is 0.04y. Negative 2,400 plus 3120 is 720, I believe. Is that right? Divide off the negative 0.04. Is it 18,000? 720 divided by 0.04 gives you 18,000? 18,000. So there's our y. So the x, easy enough. Plug that 18,000 in for y, then the x has to be, well, subtract the 18,000. $22,000. Okay? So that's our two amounts. The X amount, 22,000. Y amount, 18,000. 10%, 6%. Yeah. Yes. All right.